Merry Christmas and welcome to the first winter presentation of AQUA. Today I'll be going over what I've been working on for so long and talk about my general philosophy regarding AQUA and what exactly I want to achieve with it in the future. To start, I think it bears explaining what AQUA even is. AQUA is an ecosystem of operating system components which can be used separately or together in a way that's meant to be seamless, elegant, and intuitive. As its name suggests, it primarily aims to be as transparent and elementary as possible. The advantage of having such a componentized system is that you can pick and choose which parts you want to keep or not to build a system that can essentially be adapted to anything. For instance, you could relatively easily run AQUA's default desktop environment on a Linux OS, your own OS, or even in an application window inside of another OS. As easy as it might be to set up the components you want from AQUA on any system, it's always useful to have a fully fledged, Unix-like desktop operating system which can run pre-existing applications with everything you might need pre-installed. This full desktop OS is AQUA-BSD, a general user-oriented OS based on FreeBSD, which includes AQUA's development tools, desktop environment, virtual machine, and basic applications. For now it's in a super early state, but I'll gradually be releasing components for FreeBSD during the course of next year, before releasing it all as a single package. AQUA isn't limited to the desktop though. Another AQUA general user-oriented OS in the works is the ARA, the Android ROM for AQUA. Based on Android 11, it includes some minor niceties, although its main characteristic is its integration into the AQUA ecosystem, which I'll talk more in depth about later. Naturally, you can build any of these AQUA features on any other Android ROM you want. It will be released for the Redmi K20 next year, and will gradually receive more and more features as time goes on. Software and hardware ecosystems are very useful in theory, but their implementation by most big companies is often lacking, and I think that this is primarily due to a lack of openness. These ecosystems are great to use, but only if you limit yourself to using the company's own products, since they're usually unwilling to give up the data they collect on you, or open up their system to third-party applications and devices. Google servers, for instance, act as a big black box for the end user, who is at the mercy of what Google decides to make possible with their data. In short, you have no control over your data, and there is no way to extend or expand this ecosystem. AQUA aims to take this idea much further than it previously has had the chance to go, by creating a completely open platform anyone can use or build upon. Your data is also completely in your hands. You could absolutely decide to set up an AQUA server to run on your main desktop computer in the background, or on a dedicated server PC, for example. Here, I'm going to present a small demo to show off exactly how all this works. I've got here a screencast of an AQUA-BSD desktop computer, which is also running an AQUA server in the background, and next to me, an Android phone running the ARA linked to it. If I want to unlock my desktop, I can just open the new Android 11 power menu and tap on the Unlock Desktop tile, which will use AQUA to tell my desktop that I want to unlock it, at which point it will send over an authentication request back to my phone within a couple of seconds. This is obviously a very limited example, and there's definitely a lot more potential that will be explored in the coming months, such as seamless file sharing, wireless peripheral access, such as using your phone's microphone as an input device for your desktop, and automatic application data sharing, to name a few. Part of the AQUA ecosystem is ZV5, a 64-bit computer architecture that's made to be as hardware agnostic and small as possible, consisting of just 16 instructions and 16 registers total. This makes it trivial to implement in hardware and to make a virtual machine for. AQUA's default Z virtual machine and the one packaged in AQUA-BSD is the ZVM. All default applications as well as a window manager run on the ZVM on AQUA-BSD. The ZVM is generally integrated into what's called the KOS, which essentially handles memory management and communication between the application and virtual devices. Devices in AQUA provide a standardized interface for applications to query for and interact with external platform-specific functionalities. So, for example, if an application needed to access mouse input, it would first call the KOS's query device function to check if the platform it's running on supports mice, and then it would call send device with a standardized set of instructions to check for mouse movement, mouse button presses and releases, and so forth. Obviously libraries do that for you, so you rarely need to deal with that stuff directly. Here is a very basic example of a Z CPU core implemented in hardware on an FPGA with an MMU and all the other fundamental components needed to run an AQUA application natively. Some important features are still missing from the current Z specification though, such as shared libraries, debug symbols, and multi-threading that will come in ZV6 and future versions of the Z specification. As previously stated, AQUA-BSD comes pre-installed with all the tools necessary to develop applications for AQUA. These include the AQUA compiler, which comes with the Amber and ZASM programming languages by default. The compiler outputs a ZPK file, which is an archive file that contains the necessary assets, metadata, and Z executable file of the application. The ZPK and Z file formats are designed to be as easy to read as possible and, as such, convert to any kind of target platform which may not have or support the ZVM. As well as Z, AQUA comes with ELF64 and PWA targets, with PE32+ and Android targets planned for the future. Here is a concrete demonstration where I have some ZASM code on Linux that I'd like to compile as a web app. All I have to do is run the compiler on my source file, specify the language I'd like to compile, and the target to which I want to compile, and as you can see, a folder is generated with the output PWA, which I can expectedly run in Chrome or any such browser. The entirety of the PWA target source fits in just under 300 lines of C code, and it's pretty bare bones at the moment, only supporting the base ZV5 specification and not any of the core devices. Amber is meant as a much higher level programming language, with features like custom types, equivalent to classes in most other languages, easy string manipulation and type conversion, operator overloading, and many other useful features that are commonplace in modern programming languages. As might be expected, these tools are all available to any Unix-based operating system, although a lot of the significant changes made to the underlying architecture have yet to be pushed to the GitHub repositories. Thank you for watching the first ever winter presentation of AQUA. We've looked at AQUA BSD, the ARA, the AQUA ecosystem, and the AQUA development tools, and I'm really excited to see how AQUA will evolve in the coming years. Merry Christmas, stay safe, and have a good one. Peace.